talked about the fact before in this course that one of the reasons we study mathematics is so that we can take data from the real world and analyze it and model it using equations. And I've put 3 sets of data up here on the board. And the thing is, I would like you to look at this data, and I think 2 of these sets of data you've looked at before. Jackson, look at that first one and tell me what you're noticing.
It's linear.
It's linear. I agree with that. And how do you know it's linear?
Because the y's and the x's are incrementing by the same amount each time.
Okay. He's saying that these numbers are going up by 1 each time, and these numbers are going up by 3 each time. So if we can come up with a linear function, we would have what we call a mathematical model for this data. And I think we even did that, didn't we? This line will have a slope of what?
3.
3, okay? The rise is 3 when the run is 1, so the slope is 3 over 1, which is 3. So there's y equals mx plus b. Do we know the y-intercept, Becca?
It would be -1.
Yeah, right here. When x is 0, y is -1. That's where our line is crossing the y-axis. So that's b. b is -1, or we could just say 3x minus 1. That's the mathematical model for this set of data, okay? Now, the one in the middle, Isaac, is it linear?
No.
No. However, it is something that we talked about earlier. This time, we are still adding 1 each time when we go from 1x to the next x. But what's happening on the right side, Isaac?
Each time as it goes down, it's doubling.
Aha. So we're multiplying by 2. Instead of adding, we are multiplying by the same number. So that's not linear, but we have a name for that. Does anybody remember what the name is? It's a different kind of function. Not a linear function.
Is it exponential?
It's an exponential function. And an exponential function has a whole different look to it. It's got some number times some number to the x power. Remember that? And since we're doubling each time, doesn't that mean that this number is 2? And this time, isn't the number out in front the y-intercept? So what is the y-intercept here, Jackson?
4.
4, because when x is 0, y is 4. So there's the mathematical model for that set of data, okay? Well, the third set of data is something brand new. For several lessons now, we've been talking about quadratic functions. And this one happens to be a quadratic function. Now, we're not even going to find its equation, but I can guarantee you that it's going to look like that. It's a parabola, okay? These are points on a parabola. What I did want to show you is how you can identify it, how you can figure out if it's a parabola or not, a quadratic function. Now, right away, I know it's not linear, because here I'm growing by 2, but here I'm not growing by 2. Linear, you always have to be growing by the same amount. And I know it's not exponential either, because to get from here to here, or from here to here, or from here to here, I'm not multiplying by the same number, okay? But here's how you figure out if your data is quadratic. I'm going to take 7 minus 5, and that gives me 2. I'm going to take 11 minus 7, and that gives me 4. I'm going to take 17 minus 11, and that gives me 6. I'm going to take 25 minus 17, and that gives me 8. I'm going to take 35 minus 25, and that gives me 10. Those numbers are called the first differences. And that's what we did here, right? 2 minus negative 1 is 3. 5 minus 2 is 3. 8 minus 5 is 3. If all the first differences are the same, then it's linear. It's a first-degree polynomial function. But this time, our first differences are not the same. So what I'm going to do is I'm going to take the second differences. In other words, I'm going to do 4 minus 2, and 6 minus 4, and 8 minus 6, and 10 minus 8. And look at there. The second differences are constant, are all the same. And when that happens, that's an indication that you're looking at a parabola. Okay? So first difference is the same, it's linear. But second difference is the same, it's quadratic. Now, in an Algebra 2 course, we would go on and use this data and actually figure out what A, B, and C are. But at this stage, I'd be happy if you'll just understand that when the second differences are the same, it's a parabola, okay? That's all there is to it.